Now, talk about controls a little bit. Here's the last part of the semester. You with me? Look at this. We're in week 11. Everybody say yes.
Yes.
Then comes 12. Then comes 13. Then comes 14. That's all there is.
Right.
How about that? At least you like that? 11 is where we're finally going to get to do some experiments with feedback control. Everybody say, sweet.
Sweet.
All this stuff we've been doing up to now is prep. And now you're going to do some experiments. If you click on that, there's some instructions. Let's do that just for fun. Lots of stuff, words. Oh, first you have to find ENGR. Well, you don't know what ENGR is yet, so I'm going to tell you a little bit. And then all this stuff. And what you have already, go to another page. I'm going to do that. Click right there. What you have already, let me see, how do I get there? I want to go there. Oh, those are all teams. That's not what I want. Yeah, what is this?
I think you broke it.
Sorry, I want to go down. Some team probably has some results, right? On week 10. Just pick Jesse out of random. Here's some model results. This week, I want you to do some experiments just like you did these model results. You have some initial value of the set point, and then you change the set point. This one goes from 25 to 30, and this thing goes like this, and you observe this. So you're going to observe a real experiment that does this same thing. Now, it's not as easy in the experimental world as it is in the modeling world. So pay attention, and I'll tell you how to make it as easy as possible. First, you have to find ENGR. Well, let's talk about what ENGR is. You probably haven't. Have we even mentioned ENGR in here?
We have not.
All right, I'm going to mention it real soon. I'm actually already mentioning it. So let me do some pencil writing. And by the way, when I do pencil writing over here on the projector thing, I take a scan of it and put it on the web. Let me show you an example. Isn't there somewhere that has, oh yes, it's down at the bottom. In case y'all don't know it, there's a thing down here called Videos Galore. And like last week, there wasn't a video of what I said, but I instead made this thing here that we talked about. You remember that? Oh, okay, here's ENGR. ENGR is the M that gives you what, sorry, let me see. Here's the initial customer set point. You come over here to this line and you go down and you get ENGR. Now, how many of you put 100% confidence in your SSOC? That's what this is. How many, raise your hand if you have 100% confidence in your SSOC. All right, excellent. I'll show you how to get ENGR. All right, so let's do it this way. Oh, let me do this first. Formula for the controller, let me start here. Here's the controller. A sub C is the controller gain. That goes into the K, E minus T naught S over tau S plus 1 in this system. This is C. This is all familiar to you, I hope, right? Please say yes.
Yes.
Who said yes, Dr. Henry? Thank you, Carolyn. This is E here and M here. The formula in the Laplace domain for the controller is M is equal to Kc times E. Unfortunately, in the time domain, it's a little bit different. So I'll show you what the equation is in the time domain, because the time domain is what the laboratory lives in. The formula for, let me do it like this. M in the time domain is equal to Kc times E in the time domain plus M bar. That's what the M bar is I'm talking about. It's the thing that gets this where you want it to be. So, let me show you how to get M bar. Here's a typical SSOC. This is flow rate. Who has flow rate? Y'all people back there? Y'all the only two teams that has flow rate? So, at this point, we're going to pretend we're a customer. And the customer wants something over here. The customer doesn't care about this x-axis. The customer cares about the y-axis. So let's say the customer wants 25 pounds per minute flow rate. I want each of you in your teams to pick a different value depending on what region of the SSOC is here. So let's say I pick 25. I come over here and it looks like that goes down here. Move this up a little bit. Looks like it would be 53 would be M bar. So let me try an experiment like this. This is, what do you call this? Oh, this is R. That's the desired value of output. 53 is M bar. You with me? Step one. Decide on a set point and find M bar.
Let's use his.
Questions on that?
Can we use 25? No, it was a stupid question.
Pardon?
It was a stupid question.
There's no stupid questions. There are only stupid answers. All right, let's take a note. Here's a note. Does this look similar to the other one, only it's different? Yes.
Yes, Dr. Henry.
You said Dr. Henry. Here's something over here called pressure. Some of you have booth pressure as your parameter. All of you people over there and all of you people over here. Nobody up here, right? So let's say the customer wants 10. That's in my range of the thing. So I go over here, 10 comes down here. Looks like 47 for pressure. So that's how I find M bar. Say the customer wants that. Over here, you're going to have a 47. And bar that. Now, guess what? Some people have something like this. Can you believe that?
That's terrible.
So here, customers want different temperatures. So somewhere between 60 and 45, you pick a value. So let's pick 50. 50 sounds like a good number, doesn't it?
Pretty much.
Let's pick 50 is a R. And we come over here, and which of these lines do we go to?
Blue one.
The blue line?
Straight.
By the way, this blue line is what I observe is what is called in Excel a smoothed curve. Do not ever use a smooth curve in front of me again. That's for business majors, okay? Business majors like smooth curves. Engineers, see what that suggests is that you know enough to know what that curvature is. But you don't. You don't have any data there. So just draw straight lines. Real smooth. You're going to be amazed if I tell you this, but I don't care if you go over to the blue line or if you go over to this, what do you call this thing?
Trend line.
Trend line. I don't care which one you go to. You go halfway between. Let's go to 60. Let's call it 60. Okay. So M bar is 60. Think I'm too loosey-goosey?
No.
660.
Right, so, who said, what did you say, Caroline?
That sounds good.
Sounds good.
Looks like
All
61.
right, so that's step one. I've done it for several people. By the way, there's some people that have, what do we call that thing? Absorber flow and absorber air and absorber water flow. Does that sound familiar? I don't have your SSOC up there because I couldn't find that you've ever gotten an SSOC for that. I think that's maybe something you need to do. Oh, you want to know how to do it?
Sure.
Yes.
All right. 6 people on what? Airflow or water flow?
Water.
You're on water flow. 6 people on airflow. Each of you do one experiment at a different percentage, and you collect your data, and we'll have a SSOC. That's all. So you can do that by 5 o'clock today, and do this kind of thing. All right. So any questions on how to find M bar? Are you going to remember these or what? Huh? Redo what? Yeah, okay. Does anybody have a marker for the? I'm going to write these down so I remember. For temperature, for duct cool, and bar 60. I'm not saying that's what you have to use, but that's what I'm going to use for an experiment that I do. And then booth pressure, M bar is 47. Flow rate, M bar is 53. I'd like to know why the red marker has a blue cap on it.